Hello YouTube, I Fix It All here, Team I Fix It All. So I got my super split issue fixed. Start with this. End up with this. This is my solution to keep those dust seals in their home. I tapped the I tapped them back into place. I was able to do that. This is the second time I've tried to run this video, so I'm going to redo everything over again. This is the template for the inner race of the bearing and to integrate the 4 mounting holes that are available to me if I were to use bolt-in bearings. I didn't take the splitter apart though. I just took a couple of measurements, and since I had a couple of measurements, I was able to transfer those to a piece of material that in my mind, I wanted it to be non-metallic and also really durable. And what better way than mining belt material? When we were focused in on the bearing, we had this is where my dust shield is that I tapped back out in. This is the inner race right here. This is the dust shield, and that's the outer race of the bearing. And then there's some other tube steel that's around this bearing that's factory supplied to SUPERSPLIT, where they can tack weld it in place, as we saw in part 1. But my focus here is the here's the ball bearings. Etc. My focus is this inner race and using that inner race to my advantage for this piece. That inner race protrudes inboard. Let me see, is there anything else I want to cover? Okay, so the inner race is 2.060 inches in outer diameter. And that's all you really need to know except for the dimensions on the mounting holes. I was able to use this to sneak down inside that little metal box area to learn that the inside dimensions from the inside of each hole was 4.060 inches. And then I later determined that each mounting hole is approximately 3/8 inch diameter. So that effectively gives you a center to center on your mounting holes of 4 3/8 centers. All right. Now, when you look down inside that area, this side is you're looking down inside the box where the pinion gear is. You've got that metal box, and usually your handle is right in here. And that's to your work table where your wood lays. This is toward the engine. Looking down inside that opening, we have the pinion gear that's sitting, that's in the bearing on either side. The inner race protrudes inboard a significant amount. The inner race of the bearing, which is this outer ring right here. That's the inner race. That's the dust shield area. And this is the outer race. We don't really care too much about the outer race for what I'm doing to remedy my problem. My objective is to trap the dust shields so that they don't pop back out. Okay? What do I want to cover first? Just so you know, any type of what they call maintenance-free sealed bearing system usually has a dust shield on it. But if you're given a grease fitting and you are to add grease, and if your dust shields are all in place and properly cinched in, when you add grease, there's really nowhere for the grease to... It's hard to get the grease in there because you'll be airlocked and you'll be hydrolocked per se. You almost got to force it in. That it's actually legit science that if you intend on greasing a sealed bearing, you should get you the tiniest drill bit you can and drill 1 or 2 teeny holes. I mean, like a 1/16 of an inch. This way, when you inject grease, you can let grease flow in, and it has somewhere up high on the profile of the bearing, somewhere for some of it to weep out, so that you are actually grease in, grease out. You know you're not standing a chance of blowing your cover off like I did. That's what happened with me. I'm almost 100% sold on it now that I was adding grease, and I just blew my own seals off. But when you look down inside that metal cage, that metal area, you know, your handle is going to be about right here to lift up. You'll have your pinion gear. You'll see that the inner race protrudes inboard a little bit. That inner race is 2.060 inches in diameter. So let's just call that 2 inches. That's what this hole is right here. That's going to fit on the inner race. This hole, this hole, this hole, and this hole will accommodate the 4 mounting holes for your bolt-in bearing, but I'm not bolting in a bearing. I'm using this to trap my dust seals on the back side. And what I've got here is a thing I've made to do just that. The reason why it's shaped funky like this is because when we go outside to take a look at it, you'll notice that the I-beam is torched out. It's plasma cut. There's a notch cut out of the I-beam just below each bearing. Don't know what purpose that serves. Maybe to get a tool in there or something. For bolt-in bearing applications, I'm not sure. But that opening is what these ears are for. I'm going to be slipping these ears down in that opening. And then I just learned I can't install the 4th bolt because there's just not enough clearance to add a nut. That hole is drilled through the steel work, and it's like exactly flush with the I-beam. There's just no way to get a nut on it. These nuts that I'm using, these nuts that I'm using here are for wood, a wood application, but this is going to drop down just like this on the inboard side. I've got it split. I can wrap it around the pinion, drop it down in that slot, come on the outboard side and add 3 Allen screws. That'll keep my dust seal trapped up against this right here, this mining belt material. All right, but how did I get this template without disassembling the entire machine? Well, here's how you do it. hang on. So if you know if you have a little bit of information on your dimensions, like I knew the width of my pinion, my outer, I knew the width of my outer, my inner bearing race, and that was 2.060, so I'm just going to call that 2 inches. And then I measured, and I knew what the distance was between 2 horizontal mounting holes. I made the assumption that these mounting holes are the same, and they were. I learned that it is 4.060 inches in between the holes. So let's just call that 4 inches. And then I learned that the hole itself, when I snuck this tool into one of the holes and was able to get the width of the hole, I learned that it was 0.315 to my best abilities to measure. So I said, screw it, that's got to be something like a 3/8. So I had a bunch of information. I knew my inner race diameter. I knew my hole orientation now. Now I need to translate that onto a material that I want to pick to use. I didn't make a template. I built my template right on the material I was using. Quite literally, it was just, I was literally writing right on the mud flat material. So, hang on for a second. Yeah, so this was a larger piece of material. I just used my pencil and a light here, and I could see all the work. But if you don't, if you want to make a template first, all you got to do is, here's what you do in this situation. Get your piece of paper, draw you a straight line. Now, since I know my center to center is approximately 4 3/8, and I want to have a little bit of material left over on the sides, I'm just going to target 5.5 inches as my total circle basis, my circle foundation. So I've got a line drawn. I'm going to try to center up 5.5 in this piece of paper. That looks about right to me. I'm probably going to try to zoom you all in a little bit too, so you can see me do this. Okay. So, get my ruler on there. I'm going to find 5.5. And that's about right there. And then find the beginning, which is my 0 mark, which is about right there. Okay. We're beginning to build our template to get this right the first time, so that you reduce the odds that you have to take multiple takes at it. So here we go. You want to get your compass. You want to put your pointer right in the beginning. And this is where you got to be real conscientious of accuracy. Put your pointer right in there at the beginning, and just pull your pencil out more than halfway past the middle. Anywhere is fine as long as it's more than halfway past. And you make an arc up top. Make an arc at the bottom. And then you come over to the other side and you find that dot, and you try to stay centered up on that little dot. Make a little arc down here. Make an arc right there. Hang on for a second. Got company. Well, I have no idea where I left off, because this video is obviously not supposed to be made. But it looks like we left off on getting our arcs pulled in. Next step is you line up the intersections with a ruler. You got to be real precision as possible on this. And I hope that's right. It looks pretty close. Now we have a X and a Y axis that we can now understand where the center line is. Put a point right there. Whoops. And bring the pencil into the dot. And my pointer moved. And make sure we're lining up. There we go. And now we draw this circle. The purpose of doing these arcs was to make sure we have that perfect line, because we have established we need a material to be about 5.5 inches in diameter, which we've got about 5.5 inches, and that would be the outer perimeter of this item. Now I'm going to inject the idea that my inner race is 2 inches in diameter. So now if I can put 1 inch right at the center mark, and there's a tick mark there. Put my pointer right in the center again and bring my pencil to there. We can come up with a 2-inch radius here. Now I've got that. And since I knew that my mounting holes were 4.060 inches apart from the factory, these mounting holes that are pre-drilled in your SUPERSPLIT, the inside spacing is, let's just call it 4 inches. Then I can put 2 inches right at the intersection. There's my 2-inch mark right here, right in line with my x-axis. I can make a little placeholder dot there, put a placeholder dot here, and now I can just freehand a circle right here and a circle right here. This would be a 3/8 hole. That's a 3/8 hole. And then on my other axis, I line up the 2-inch mark again, put a placeholder dot there. That's 1, 2, 3, 1, 2, 3, 4. And on the outside of each little placeholder dot, I freehand me a circle, because I know that's going to be a 3/8 hole. Now I've got my template, and I used this hole saw to cut my 2-inch hole out of this piece here. This is a Bosch hole saw that comes with a bunch of bits that all store right inside this tool. All kinds of cutting discs, but it's made by Bosch. I love this hole saw. And then I used my 3/8 punch to punch out my holes. And since I've already installed this once, these are wood anchors like you would find on the bottom of a chair, like a swivel stool or something. They're anchor nuts for wood. And the reason why this is notched out right here is because, back to this, when you're looking down inside the box where the handle is and you got your pinion gear, a piece of the I-beam is notched out just below the bearing on each side. I don't know what that's for. It might be for tool access or something. I don't know. But I'm using that to house this portion. I learned I can't install a bolt on the bottom because there's just not enough clearance. I can't put this bottom one in. So let's go out and demonstrate. Hang tight. Okay, again, my only objective is to trap this dust seal to keep it from not falling out again. So I'm going to fight this in because it's split, and I'm going to be using that slot that's below the pinion gear. There's a hole torched out of the I-beam itself. Okay, that's in. Now you see what's going on? Well, I chose to use these Allen screws that I had to cut short, custom length them. But I'm going to be installing the Allen screws on the outside. And I think first what I'll try to do is just get them started if I can. Okay, that one's started. Remember, I said earlier I cannot get the bottom one in because there's no clearance. Okay, that one's started. Oh, you kept my socket. Okay. Let me get the other one in. There we go. All right, I'm going to begin tightening. Okay, that's tight. Get this one tight. That one's tight. And that one's tight. Okay, let me show you. You can probably see all that from where you're at better than I can. What's happening here is that 2-inch opening I cut in this mining belt material is surrounding the outer race. The rest of the belt material is blocking off the dust cover and preventing it from falling out again. And those two little ears that go down in there was intended to take a bolt of its own, but there's no clearance. But since it's down inside that slot, it ain't going nowhere. This material is heavy duty and durable. It should be capable of taking impacts if it needs to. Notice my bolts are flush with this anchor. And if we go around to the other side and take a look, we'll notice that my Allen screws are also really small and almost effectively countersunk. And there's the other one. Now on this side I have to put my Zerk fitting back in, or my grease fitting. But I had to take it out to get clearance for that bolt. So there's my solution for ensuring the dust seals, if they come loose, I don't have any worries because I have a bearing buddy, whatever. And so far, none of this cost me any money. Now I can inject grease to my heart's content, and this mining belt material will have some give. The dust seals may come dislodged again, but they're just going to hit the back of this and stay trapped. So I would expect in the future to see grease excreting around this protective barrier I've installed. Alright guys, now it's basically wash, rinse, and repeat for the other side. Whew. Third time I tried to do this video. Did I forget anything? No. Yeah, that's it. I think that's all. That's all. I did get a call back from SUPERSPLIT today. Paul, if you're watching this, this thing is a workhorse, and it's never broke. It wasn't. And everybody else, my machine's not down. I mean, worst case scenario, that's a 200 RPM bearing, really low RPM. I don't have any reason to be replacing bearings. What I can do now is I can be really I can really have confidence that if I want to really add a lot of grease to trade out the old and replace with the new, I can just keep pumping away, because I know those seals and all those metallic objects aren't going to get in here and get lost and get in between my rack and pinion and destroy this. I guess now what I'm going to do is all the parts that I have to put back in, I'm going to do some preventative maintenance on them and inspection. I'm probably going to do that mod I've been wanting to do on this piece here, which is make something that looks like a snow plow on the front out of stainless and shape it so that it scrapes the top of the I-beam every time it goes forward and goes back. And I'm going to be utilizing these 6 bolts to hold down an object that'll act like a snow blade so that no splinters get to underneath this, because anybody who owns a SUPERSPLIT knows if you get a splinter underneath your sled, you're up here with a sledgehammer beating that sucker to make it retract. Another thing I noticed that I need to do is these guides here for the rack, I've got to bring those in closer, and I will probably allow them to have a sufficient clearance, but right now it's over clearanced. I don't know why, but this is just a nylock nut and an adjustable bolt here, so I'll play around. That's it for this video, guys. Problem solved. What I did over here, I got to do over there. See ya.